In your mind, you may have thought of who we are connected to through the internet. Although it seems too simple, most people will think that connecting your phone or laptop to your Wi-Fi is all they need to do, but that is not the case. While we have wireless connections to our distributors for transmission, most of our cables are underground and are located at the bottom of the ocean. As a matter of fact, the world is connected by gigantic cables that are buried beneath the ground. You're watching your favorite YouTube channel. In today's video, we are going to talk about how the world is connected through the internet. Before moving forward to discuss about internet, make sure to subscribe to the channel and hit the bell icon, so you won't miss any future videos we upload. Getting back to the video, the vast majority of anything you see on the internet, including presumably this video, is transmitted to you from deep within the Earth's oceans. In fact, almost all of the data that is transferred across international borders is carried out by means of a complex network of cables that are laid out on the seabed of the world's oceans. In 1886, transatlantic cables were laid for the first time in the oceans for the first time, resulting in ocean cable internet. Up until this day, cables remain the technology of choice despite shark attacks. This is primarily due to the stability and dependability of cables rather than that of satellites and other means. Around 436 submarine cables will be operating by the year 2021. Cables are always being installed and removed, so the total number of cables is constantly changing. For internet cables, copper wire was used in the past. The submerged communications cables of today use fiber optic technology. Lasers are positioned at the end of the cable that fire at extremely high speeds through tiny glass fibers to receptors located at the other end of the cable. Often, these glass fibers are also encased in multiple layers of plastic and steel wire to ensure their protection. In most cases, the width of a cable is comparable to that of a garden hose when it travels across the ocean. There are several layers of insulation and protection surrounding these fibers at all times, with a diameter that is about the same as a human hair. Light signals are transmitted by filaments that are as thin as human hair. To make cables safer, more layers of armoring are added to cables that are installed near the shore. In order to prevent damage, cables closer to the shore are buried beneath the seabed. This is why we don't see wires near the beaches, because they extend all the way into the depths of the ocean. Those cables laid further out in the ocean, however, are laid directly on the ocean floor, which is why sharks often bite them. Cables are carefully routed in a way that is least hazardous, of course. To avoid fault zones, fishing zones, anchoring places, and any other potential hazards, this is necessary. Are you wondering where these cables are? The location of these cables can be found on telegeography's submarine cable map. Nearly all countries with coastlines are connected by submarine cables. Multiple cables are used by most countries to ensure a reliable connection. In the past, telecom firms have held these internet cables. They create partnerships with any other parties interested in utilizing the cable. At the end of the 1990s, there was a rise in the number of business-minded companies that built a large number of private cables and then sold their space to consumers. A significant shift has taken place in the types of businesses that are participating in the construction of cables over the past several years. Google, Facebook, Microsoft, and Amazon are among the major investors in new cable infrastructure. During the past few years, private network operators, including these content providers, have added more capacity than internet backbone operators had deployed. A submarine cable upgrade makes financial sense for these companies because it has more bandwidth and is therefore able to reach more people. 100 cable errors occur every year, but why do we not hear much about them? Many companies that use cables use a strategy called safety in numbers, which involves spreading their networks across multiple cables to ensure their security. Consequently, even if one cable breaks, the company's network will continue to work normally with the other cables until it is repaired. Also, 2/3 of cable problems result from accidental damage caused by fishing vessels and ships that drag their anchors. The damage can also be caused by natural disasters, such as earthquakes and extreme weather events. It is much less likely for components to fail when submerged in water, and shark attacks are extremely uncommon. In fact, human activities lead to the most damage. Apart from that, these cables have a minimum design life of 25 years. Although these cables may continue to operate for more than 25 years, economic obsolescence usually leads to their decommissioning much sooner. At that point, they will be unable to deliver the same capacity as modern cables at an equivalent cost, so they will be decommissioned as they cannot deliver the same capacity at the same cost. A cable may still be present on the seafloor even after it has been turned off. Who dragged them out? For this purpose, an increasing number of businesses have bought rights to cables and are pulling them up to salvage raw materials from them. It is possible to reroute decommissioned cables over alternative paths after they are pulled out of the ocean. It is possible for ships to retrieve retired cables from one place and then relay them along the new route. At the various landing stations, new terminal equipment has been installed. In countries that don't need a lot of capacity and don't have much money, this could be an ideal strategy. Aside from that, many of these fiber cables can still be of some assistance even when they are cut off and lying on the seabed. Scientists use these cables to conduct seismic activities in order to determine the magnitude of earthquakes. Even though they are cut off, they still radiate the signal, making it very useful for scientists. Lastly, let's examine how cables are installed on the seafloor. Cable-laying vessels can transport up to 2,000 kilometers of cable at a time before they can be laid at sea. Some of these vessels are capable of transporting up to 2,000 kilometers of cable simultaneously. It can take up to 3 weeks just to load the cable, but with the right equipment, it can be laid at a rate of about 200 kilometers per day. As soon as the cable is loaded onto the vessel, it is laid out along the shore until it reaches the water's edge. The ship that is laying the cable approaches as close to the shore as it can safely without running aground, and then digging begins. Ships are used to draw a form of plow that simultaneously installs cable and drills a trench for its placement. It may be necessary to pick up and relocate cables if they pass over one another or cannot be buried due to some reason. When calculating the ship's path across the ocean, mountains, valleys, coral reefs, rocks, and fault lines are all taken into account. A considerable amount of time and effort goes into preparing the cables, which should be placed in areas where boat anchors and fishing trawlers will not damage them. To save time, 2 ships may begin the procedure at 2 different sites, lay cable between them until they meet, and then connect them together. That was all for today's video. You can share with us your views in the comments section. And if you are new to the channel, remember to subscribe to the channel and hit the bell icon so you won't miss any future videos we upload. Thank you for watching the video. Best of luck and goodbye.